Hello everyone, in this video we will be solving a hard problem number 84, largest rectangle in an histogram. The problem statement is, we are given an array of integers heights representing an histogram's bar height where width of each of the bar is 1. We need to return the maximum area or the largest rectangle that we can build in the histogram. In example number 1, based on this input, the maximum area of rectangle that we can build is between 5 and 6 with the width of 2 and the height of 5. Hence, our output is 10. There are several algorithms and solutions available to solve this problem. The simpler solutions involves the time complexity of O of n square, where you will be iterating through this array multiple times to get the width for each bar and then calculate the area. Because the time complexity is huge, it is not a good solution. Hence, we will be trying to solve this problem with the time complexity of O of n using stacks. So without wasting any more time, let's switch to whiteboard and talk about how this can be solved. If I try to identify the different scenarios that we will be coming across when solving this problem, I can break it down into 3 different categories. One is when the difference between the corresponding bars is growing. So the value at index 1 is greater than the value at index 0. This is one situation. The other is the value is equal. And the third is where the value is decreasing. So if we compare the second and the third scenario where the value either is equal or it is decreasing, for each bar, if we are trying to compare the area that it could cover, we can use the same formula. The reason being is when the value is decreasing and I want to check the area that it could cover between this bar and all of the previous bar, or at least the bar just before it, I can easily take the height of the current bar and multiply it by the width, which will give me the area. Because I know for a fact that whatever is the height of the current bar, I have at least that much height in the previous bars. And similarly, when I look at the scenario when I have the heights as equal, I can easily say that the total area of rectangle can be summarized as the height of the current bar into the width. But this logic cannot be applied to the situation where the bar is increasing. Because if I look at this scenario for 2, the height is 2, but the bar before that is lower. So I cannot go behind or go left and calculate the rectangle with a height of 2. I need to go with the height less than that. So based on the previous bar or previous index value. This is going to be the base logic when we are building the algorithm to solve it. I hope you were able to follow this differentiation. Now that we have a clear understanding about these 3 scenarios, let's switch to an example and try to solve it. So now let's use an example where we have 3 inputs, where we have 3 elements in the array, 1, 2 and 4. So I have created this stack that will hold the values. This is going to be the formula that we will be using whenever we encounter a certain situation, which I'll talk about it in a minute. The approach is to start iterating throughout the array. So when I start my iteration, my pointer I will be pointing at 0. So the value will be 1. Now I need to check if there are any values in the stack which I have previously entered. And because my stack is empty, I cannot do any calculation. So I will add the index 0 to the stack and increment my I. It will make more sense in the next scenario. When my I is 1, the height of the element at index I is 2. Now I need to compare if this value is greater than or equal to the last value that was added to the stack, heights of then stack.peak. If this condition is satisfied, I do not need to do anything because the value is increasing. So I will just add the new value I to the stack and then increment my pointer. So with I is equal to 2, my value will be 4, and with value is equals to 4, again I will check with this condition. So 4 is still greater than equal to the last value that is there in the stack, which is 2. Hence, I will add this new value of I into the stack and then increment my pointer I. So now my new value of I is 3, and with I is equal to 3, we are out of bounds with the array. I have everything inside the stack, but we haven't calculated any maximum area yet. So now to continue the calculation, we will take the last element from the stack. So the top value will be the value in heights at that index. So right now the top value is 2. So at index 2, the value is actually 4 in the heights array. At that point, my I value is 3. So now if I check the condition, is my stack empty after doing the pop? It is not empty because I still have 1 and 0 in it. So I will go in the else condition to calculate the area. So the formula is heights of top, which is 4, into I, which is 3, minus stack dot top. What is at the top of the stack? We have 1. So I'll take 1 and then minus 1. So my result is 4 into 1. So my result is 4. And I will also monitor a max area variable that will be updated if we find the area greater than the previously calculated value. So for now, when we started off, because the previously calculated area was 0, this maximum area will now be 4. And if you look at the graph, so when my I is 3, I am at this position. Histogram bar that we are using over here is this part. The height being 4, which is the stop value, and the width is only 1 because there is no other index with having a value equals to or greater than 4. Now we will run the same logic again. So we will pop out the last value from the stack. So now the new value is going to be at index 1. So I will remove this. So at index 1, the value is 2. The height is 2. I'll put it over here. My I is still 3. And based on this formula to check if my stack is still empty, it is not because I have 0 in it, and I will go inside the else part and calculate the area, which will give me 4. And this calculation is based on these 2 points where the height is 2 and the width is 2 as well. So if you multiply the 2, we get 4. We will continue the same loop. If I'll do a stack.pop, I will get 1 because the index is 0. Then I will check if my stack is empty. Yes, now it is empty because I took away 0. So I will go inside the if condition, and the formula is slightly different here. The formula is heights of top, which is 1, into value of I, which is 3. Result is 3, still not greater than maximum area. So my maximum area will still be 4, and we will return this at the output. So here in this example, I have a combination of input which is increasing and decreasing. So starting with the loop where my I pointer is pointing at 0, because we do not have anything in the stack, I will add this index directly and increment it. Now I have to compare if the value at index I is greater than or equal to with the value that was last added to the stack. So here my current value is 1 and the last value that I added was index 0, so its corresponding value is 2. This condition is not met, which means that I need to do things slightly different. So I need to pop this value out and use this formula to calculate the maximum area. The reason being is if I were to build a rectangle with height 2 and move towards its right, I cannot proceed because the next value after that is 1, which is less than 2. So definitely I will have to reduce my height to 1 so that I can have a consistent rectangle. And because of that reason, we will have to pop this value out, do the calculation with all of the values before it, calculate the maximum area that we could have built so far, and then save it. We will start a new iteration or a new flow with value 1 or index 1. We will use the same logic every time we encounter a situation where the previous value is greater than the current value. So I will pop out the last value or top of the stack and use this formula to calculate the maximum area. Just like before, my top value at this moment is going to be 2. I for now is 1. So based on the formula, I will check if my stack is empty. So after popping out 0, yes, my stack is empty. So we will go inside the if condition. The formula is heights of top, so which will give me 2 into I, 1. So result is 2. So the max area will become 2. And this logic needs to continue until we have a situation where previous is not less than the current. We will cover that in the next example. We will add this new I1 into the stack, and then increment I. So now my I value is 2. At index 2, the value is 2, and the last value that I have added to my stack is 1. Is this condition satisfied? True. So just like the previous example, we will add the value 2 or I is equal to 2 to my stack. Now I have two entries over here and I will increment my counter. So now I am pointing at 3. At index 3, the value is 4. With stack.peak, it gives me index and the corresponding value is 2. This condition is still satisfied. So I will add I is equal to 3 into my stack and increment my pointer. I'll just update the value of index 4 to 1 because it will give us a better idea about what we need to do when we have multiple elements in the array greater than the current value. So I'll just make that as 1 and update the value over here. So now I'm looking at 1. Is 1 greater than or equal to 4? Your answer is false. Hence, we need to now start popping out the values. And based on this formula, we need to pop out the last value, which is index 3, and its corresponding value is 4. My I is 4. So after removing 3, is my stack empty? So we will go inside the else condition. So the formula would give us heights of top, which is 4 into I is 4 as well, minus stack dot top. So now I have 2 at the top minus 1. The result is 4. Area is 4. It is greater than the current max. So I will update that. So if you look at the histogram, this 4 is actually the area with the height 4 and width 1. This is what we are calculating. Now we have to check again if the pointer at which I is pointing at is its value greater than or equal to the stack.peak or the top value in the stack. Right now it is pointing at index 2, so its corresponding value is 2. It is still greater than the current value of I, hence our result is false. We will execute this logic again. We will pop out the last value. So at index 2, the value is 2. My I is still 4. So my area will be 2 into I is 4 minus stack dot top. So now after popping out 2, my stack dot top is 1. This will give me 4 and it is equal to the maximum area, so no changes there. And if you look at the histogram, we are now covering this case where we have the height as 2 and the width as 2. Just like before, we will continue this iteration. So we will now check if the current value, which is 1, is it greater than or equal to stack.peak. Now stack has an index 1. So at index 1, the value is 1. So this condition is met. And because this condition is met, we do not need to execute or run this formula again. All we need to do is push this index I is equal to 4 into the stack. I will have 4 in the stack and I will increment my pointer. So now my I will be 5 and we are now out of bounds of the array. Just like before, we need to check if my stack contains any entries. It does have an entry. So we will execute this formula. So I will do a stack.pop. So the last value is 4. I will move it out. So the new entry in this table would be at 4. The top value is 1. My I is 5. So the area would be 1 into 5 minus 1 minus 1. So the result will be 3. Here we are now covering this part. So my area will be 3. It is not greater than the max, so max will stay the same. So now I only have one entry, so I will check if my stack is empty. It is not. So we will pop out the last added value, which is at index 1. And at index 1, the value is 1. Now we do not have any value in the stack. Check of is stack empty will return true. So we will go inside the if condition. The formula is heights at top, which is 1 into I, which is 5. So the result is 5. Area is 5 here. Is it greater than the current max? Yes. So my new value or the new maximum area is 5, which is what we will be returning. So with this solution, our time complexity is O of n, as we are only iterating throughout the array once, and our space complexity is O of n, as we are using this stack to store the values of indexes greater than the previous ones. So at some point in the worst case scenario, we could end up having the stack length equal to the number of elements in the heights array. Hence, the space complexity is O of n. Let me show you how this same solution can be implemented using C#. Here is my solution in C#. In the main method, I start by initializing a return variable which will hold the maximum area of the histogram. Then I have a validation to check if the heights array is not null and the length is greater than 0. The next step is where I create the stacks of type int and push the index 0, because I will be starting with that, and that is definitely going to be inserted. After that, I start the for loop starting from index 1, because we have already covered index 0 there. So starting from index 1 all the way to the end of the heights array. Then I check if there are any values in the stack. If the stack is empty, it means we do not have anything to compare the current value with. So I just skip the calculation and directly go and add the index I to the stack. If the stack is not empty, then I'm comparing the current height at index I with the previously added index to the stack. So I call stacks.peak to get the last value added, and at that index I get the value in the heights array. Compare the two. If the current height is less than the height of the last added index to the stack, in that case I will go inside this if condition, run a while loop until the stack is not empty and the value of the last element added to the stack is greater than heights. If any of the condition is not met, it will jump out of while loop, and inside this I'm calling this helper method which runs the two formula that we talked about. So it will first pop last element from the stack, check if there are any more elements left in the stack. If the answer is yes, it will then use the formula heights of top into I minus the last element in the stack minus 1. If the stack is empty, then it will run the formula heights of the top element into I. Once the helper method execution is complete, I am comparing it with the current return value, and whichever is higher will be saved to the return variable. Once it is complete, I will add the current I to the stack and continue the for loop. After the for loop is complete, I am checking in case if there are any elements or any entries in the stack left. If there are any, then I'm running this while loop which will call the helper method and calculate the area based on the values or based on the indexes in the stack. If we run out of the entries in the stack, it will jump out of the while loop and we will have the value or the maximum area in this return variable, which is returned on line 32. Thank you for watching this video. I hope you were able to understand my explanation and the solution to solve this problem. If you have any questions, concerns, or comments, feel free to share it with me in the comments below. This source code is available on my GitHub repository. I will be adding the link in the description below. Feel free to check that out, and I will see you in the next video. Thank you.